guys, lesson 1.5 takes us into parametric relations and inverses. Now, parametric relations, not something you've really seen before, and to be honest, not something you work with a lot in pre-calc. Inverses, you have seen inverses before. You saw them in Algebra 2. You probably saw them in Algebra 1, and you do work with inverses a lot. Okay, that's something that keeps coming up. So, now, a little bit of definition. An implicit relation. So a relation defined implicitly. Okay, when we talk about a relation defined implicitly, and we'll see some of those today, that's a relation where it may be a function, it may not be, but it's not specifically solved in terms of y. Like, personally, me as a math person, as a math teacher, I prefer when my equation is y equals blank. It's easy to graph. It's easy to plug into. That's the easy pieces. Now, here, so for example, this first equation here, in the first example, x squared y plus y squared equals 5. That's an implicitly defined relation, okay? So it's not a y equals, okay? If it's y equals, it's explicitly solved. Something like that would not be easy to solve, and it wouldn't be easy to graph, okay? So it wouldn't be easy to solve for y equals. Okay, so little vocab there. Example 1, pretty basic, I think. Determine which of the ordered pairs, 2, negative 5, 1, 3, and 2, 1, are in the relation defined by x squared y plus y squared equals 5. And then a secondary question will be, is the relation a function? Hold that thought for later. We'll come back and talk about that at the end. So how do we want to determine which of the ordered pairs are in this relation? What do you think, Addie? Plug and chug?
Yeah.
Plug them in, see if they work, right? So with the idea, of course, I don't have to remind you guys, 2, negative 5, what do we know about an ordered pair? X, Y, right? So if we start plugging them in to, what's my equation? X squared y plus y squared equals 5. So plug them in. 2 squared times negative 5 plus negative 5 squared. And then the question, it says equals 5, but that's really the question there, isn't it? Does it equal 5? So, do some math with me. 2 squared is 4 times negative 5.
Negative 20.
Plus, what's negative 5 quantity squared?
25.
25. And what's negative 20 plus 25?
5.
And what do we know?
5 equals 5.
5 equals 5. So, to answer the question, is the ordered pair 2, negative 5 in the relation?
Yes.
Yes, it is. Okay, so 2, negative 5. I'm going to say it is in the relation. Okay? Now, is that the only one in the relation?
No.
We don't know yet, right? So you need to check. Don't just assume, oh, that one works, none of the rest do. We know, you guys know, there can be more than one correct answer, can't there? So, let's repeat the process with 1, 3. So, x squared y plus y squared equals 5. And this time we're going to try 1, 3. So what do we know? 1 squared times 3 plus 3 squared. Does it equal 5? 1 squared is 1 times 3 is 3. 3 squared is 9. 3 plus 9 is 12. Does 12 equal 5? No. So what do we know? 1, 3 is not in the relation. Okay? And, are you guys ahead of me? Check the next one, right? X squared y plus y squared equals 5. Plug it in. This time I'm trying 2, 1. So 2 squared times 1 plus 1 squared equals 5. What do we know? 2 squared times 1 plus 1 squared. Does 4 plus 1 equal 5? And yes. So we also know that 2 comma 1 is in the relation, yes?
Yeah.
Okay. So determine which of the ordered pairs are in the relation. We found that 2 comma negative 5 and 2 comma negative 5 and 2, 1 are in the relation. We found that 1 comma 3 is not in the relation. Now, the other question. Is the relation a function? That is the other question we have to ask. Is the relation a function?
No,
Why not?
because the two x's are the x parts are both the twos, so it repeats.
Okay. What did we just find is in the relation? We found 2 negative 5 is in the relation, and we found 2 comma 1 to be in the relation, yes? What do we know if something's a function? The x values cannot repeat. Or differently put, an x value cannot pair with 2 different y values, right? And if you think in terms of a graph, 2 comma negative 5 would be right 2, down 5. 2 comma 1 would be right 2, up 1. Those 2 points fall on the same vertical line. They would fail the vertical line test. So, with that in mind, that right there is your clue. That this is not a function. One thing we talked about last week when we were reviewing for the quiz. I'm not going to use the word always, because as soon as I do that, that can get me into trouble, right? But I see a y squared here. That's a red flag to me, that there's a strong chance it's not going to be a function. Okay? Just like if I see a plus or minus sign in there. That's a strong clue to me that it's likely not going to be a function. Okay? Are we okay with this concept? Okay, moving on. And that really wasn't anything new there. Maybe looking at it in a different light, but not new. Okay, our next topic is talking about relations defined parametrically. And so when we talk about this parametric relation, it's a relation where both elements, x and y, of a relation are defined in terms of a parameter t. So basically, it's bringing, it kind of looks like it's bringing a third variable into it, but we're not going into a 3-dimension thing. Okay, we're still in 2 dimensions, but they are defined in terms of a parameter t. So if you look at the example we're getting ready to talk about here, x equals t plus 1 and y equals t squared plus 2t. This is a parametric equation. Okay, it's parametric because we can and we will put those together and we can make one equation just in terms of x and y. That's what those two represent. They represent one equation in terms of x and y. But they're represented in a parametric form where it's x equals and y equals in terms of that parameter, which is typically known as t. Okay? So, we're going to do 3 different things here. First of all, A asks us to find the points determined by t equals -3, -2, -1, 0, 1, 2, and 3. What do I mean find the points? What is typically a point? X and y. So I'm asking us to essentially find x, y ordered pairs. What did they give us? T values. They gave us parameter values. Do you see how we can do this? Take your T values. And what I'm going to do, I'll tell you, I have a lot going on in all this space here. Just saying. So I'm actually, this is part A. I'm actually going to squeeze part A in over here on the right. If you don't put part A over here, you can squeeze a different part in over here later. But I'm going to set up a chart. The first chart, the first column, is going to be my T column. Okay? As in, oh, I don't need to go all the way down there probably. What are my T values? -3, -2, -1, 0, 1, 2, and 3. Okay? Now, what else do I need a column for? I need a column for X. How are we going to find X? We're going to do T plus 1. I also need a column for what? Y. How are we going to do Y? T squared plus 2t. And not that you'd have to, but I'm going to put one more column. And that column is going to represent our final answer, the ordered pairs. Sorry, I probably should have warned you a little bit that I was going to do 4 columns. Set it up how you want. This is just me trying to be organized up here. Trying being the key word. Okay, so what do we know when t is -3? What do we know about x?
-2.
Because -3 plus 1 is -2. Okay? What do we know about y? No one done the math yet? I'm not going to show the work for all of these. I'm just giving you an example. If you put -3 in, because that's the t value again, -3 squared is 9. 2 times -3? And 9 plus -6 is 3. Again, I'm not showing the work for all of them. I'm just getting us started. So what's my ordered pair for this one? -2, comma 3. Can we repeat that process?
Yeah.
Yeah. Do I need to show any more work?
Yeah.
Okay. So put in -2 to find x. What is x when t is -2? -1. What is y when t is -2?
0.
And the ordered pair of? -1, 0. Put in -1 for t. X is?
Oh, 0.
-1 plus 1 is 0. Put in -1 for t over here.
1.
-2. Would it be 3?
I don't think I've heard what I want to hear yet.
Oh wait.
-1.
-1.
There we go. Had I heard that and overlooked it?
I don't think so.
I don't think I had. I think I heard everything around it. But so -1 squared is 1. 2 times -1 is -2. 1 minus 2. Yeah. Okay, put in 0. 0 plus 1 is 1. 0 squared plus 2 times 0?
0.
Ordered pair of? 1, 0. Put in 1.
2.
1 plus 1 is 2. 1 squared plus 2 times 1?
3.
Ordered pair of? 2, 3. Put in 2. 2 plus 1.
3.
2 squared plus 2 times 2.
8.
And ordered pair of? 3, 8. And put in 3. 3 plus 1?
4.
And 3 squared plus 2 times 3.
15.
9 plus 6, 15. Ordered pair of? 415. Okay. A little tedious work there, but you got the idea, right? Parametric relations, if they give you a t value, you can find an ordered pair, an xy value. Okay, that's the parameter. It's connecting them. Now, another thing we're going to do. Part B. Ask us to find an algebraic relationship between x and y, and then it's going to ask us, is y a function of x? Okay. I'm going to come over here with B. Find an algebraic relationship. Basically, I want to take my two equations, okay, my x equals and y equals. I want to combine them into one equation where we have x and y, but t is gone. So, I don't know if you're processing how we can do this yet. My suggestion, pick one of those equations and solve it for t. Which equation is going to be easier to solve for t?
X.
The top one, yes. So I'm going to take x equals t plus 1, and if I'm solving that for x, what's that mean? Or excuse me, solving that for t? Subtract 1, and what do we know about t? T is equal to x minus 1. So, first step, pick an equation and solve for t. We did that, right? Next step. What do you think we're going to do with this? Take this and plug it into your other equation. The equation you haven't used yet. So in this situation, the equation I haven't used yet is y equals t squared plus 2t. Think substitution here, folks. Every place I see a t, I'm replacing with x minus 1. So y equals, instead of t squared, I'm going to say x minus 1 quantity squared plus, instead of 2t, 2 times x minus 1. How do I clean it up?
You have to FOIL the one.
Distribute, FOIL, all of the above. Okay, so realizing, how talented are we pre-calc? Do I have to write out x minus 1 times x minus 1 beside each other to know to FOIL them?
Yeah.
Okay, x minus 1 times x minus 1.
X squared
X squared, that's first.
minus 2x.
Outsides are minus 1x. Insides are minus 1x, so that's a minus 2x. Last,
Plus 1.
minus 1 times minus 1 is plus 1. And then don't forget, what else do we still have?
2x minus 2.
Plus 2x minus 2 when you distribute the back end.
That 2x is canceled.
She says 2x's cancel. What do I end up with then?
Y equals x squared minus 1.
X squared minus 1. Okay. If you are I need to write down what step I did. In order to get this, we plug t into the other equation. Okay. We picked the x equation to solve for t because it was easiest. Make life easy on yourself. Pick the one that's easiest. Okay? It'll work either way, technically. It's substitution. Pick the one that's easiest. Now, we had a secondary question here. We found the algebraic relationship. That's y equals x squared minus 1. We were also asked, is y a function of x? Now, that's a fancy way for saying, is this a function?
Yes.
Mhm.
It's a parabola.
Okay? Is that a fair answer?
Yep.
She says, yes, it's a function. Her explanation is it's a parabola. What do we know? Y equals x squared minus 1. What do we know about x squared minus 1?
Shifted.
Parabola. Move down 1, yes? So, and a parabola is going to pass your vertical line test, yes? Okay, so I'm just going to write here, yes, it's a function. Okay. Officially, part C, graph the relation on the coordinate plane. Now, I'm going to put C here. I kind of have extra spacing. And as I draw my graph, I know it's coming, so take that into account. I am dropping my x-axis low because I need more room to go up than I do down. Because look at my ordered pairs here, folks. Right? Those ordered pairs having me only going as low as -1, but going as high as 15. Okay? So there is my makeshift graph. What? I need to be able to go 2 left, 4 right. Technically, I need to be able to go 15 up. Did I go 15 up in my notes? I'm not sure I went 15 up in my notes, to be honest. Oh well. Make sure you can go at least 8 up. Okay, I'm going 15 up. If you miss a dot, you miss a dot. I'm not stressed about it. Okay, guys. When t was -3, what did we find? We found the ordered pair to be -2, 3. When t was -2, we found the ordered pair to be -1, 0. Here's what I forgot to do. When t was -1, we found the ordered pair to be 0, -1. I forgot to go down 1. There we go. When t was 0, we found the ordered pair to be 1, 0. When t was 1, we found the ordered pair to be 2, 3. When t was 2, we found the ordered pair to be 3, 8. And when t was 3, we found the ordered pair to be 4, 15. Okay. Does that look like what you would expect it to look like? Huh?
Is it like a Nike symbol? Swoosh.
Okay, we could call it a Nike symbol, but what is it in reality? A parabola shifted down 1. Did you guys already call that? So it's good news that my ordered pairs are matching that, isn't it? Okay. Hopefully, are you seeing how all 3 parts go together at this point? My ordered pairs on my graph match with my algebraic function that we could have just graphed y equals x squared minus 1. But I'm trying to make the connection here. It all goes together. Okay. Now, technically, I'm graphing the relation. I'm graphing the whole thing. I mean, I guess nothing says for sure, you know, I don't know if I have to go that high there, but we can see where it's continuing, right? I'm trying to think about when I usually involve the graphing calculators in this lesson. I don't remember. So there's something called parametric mode on your calculator. And I'll show it come homework time. Remind me. Okay, I'll show it tomorrow. But there's something called parametric mode. Yeah.
I see it.
So it totally changes, but you can graph using parametric mode. So I will show that. Remind me tomorrow. Okay. I'm gonna keep us moving right now, but
Change it back. I'm scared.
yeah, don't put. It does change some settings on your calculator, like you won't be able to graph normally in parametric mode. You'll have to use parametric mode. So, okay. Questions for right now about parametrics? Okay. Okay. The other topic we're going into is inverses. And really, a lot of the rest of the lesson, in somehow or another, relates to inverses. Let's go back to the basics, okay? A lot of this is going to sound familiar, although there is a little bit new. Do you remember anything about inverses from algebra? The word is familiar. You remember that we learned inverses in algebra.
Can't lie, dude.
Okay, past that, it's a little foggy. Fair enough. Okay, so if an ordered pair A comma B is part of a relation, then the ordered pair BA is in the inverse. Okay, one of the ways we talk about finding inverses is take an XY ordered pair and flip it. If XY is the regular function or equation, then YX is part of the inverse. So basically, for an inverse, your input and your output will switch. Okay? Now, so that's one thing right there. If AB is part of a relation, then BA is in the inverse relation. If a function has an inverse, notice we're going to introduce something called the horizontal line test. And that's if a function has an inverse. Okay? Not every equation is guaranteed to have an inverse, but if it does, it passes what is called the horizontal line test. What's the horizontal line test going to be? You draw a horizontal line, and if it passes the horizontal line test, that means it only crossed through the graph once. Okay? We'll practice. So just like the vertical line test, except horizontal. Now, new vocab. Functions that have inverses are called one-to-one. If a function has an inverse, it's one-to-one. Because if it's a function, it had to pass a vertical line test. And if it passes the vertical line test, that means your x values don't repeat. Well, if it has an inverse, it has to pass the horizontal line test. If it passes the horizontal line test, that means your y values don't repeat. So if x doesn't repeat and y doesn't repeat, then it's one-to-one. Each x, each y match up once, and that's that. Okay? You did see this in Algebra 1. The inverse of a function is written as f inverse of x. So you put that little -1 outside the f. You did see that. I know I used that in algebra. Algebra 2. And then to find an inverse. We did this in algebra. To find an inverse, you're going to switch x and y and then solve for y. And that function becomes your inverse. We're going to do some of that on the back side of the notes. And again, I know you did that in algebra 2. Not saying you remember it, but you've seen it. Okay? Okay. Now, real quick, I just saw something I have written here. If a function, I'm backtracking for a brief moment, is one-to-one. If it's a function, what do we know about it? It has to pass the what? If it's a function, it had to pass the vertical line test. If it has an inverse, what do we know? It has to pass the horizontal line test. So what's that mean about if something is one-to-one? No. What's it going to have to pass? It's going to pass both vertical and horizontal line test. Okay? So if something's a function, it passes my vertical line test. If it has an inverse, it passes the horizontal line test. If it's a function that has an inverse, it passes both tests, and it's what we call one-to-one. Okay? Keep that in mind as we turn to the back page. You ready? Okay, fun part. Which of the following graphs are? And there's two questions. A, we're going to answer A and B for every graph. Which of the following graphs, A, is the relation a function, and B, does the relation have an inverse? So, on each question, I'm going to answer A and B. Graph 1. Is this a function?
Yes.
Yes, because why?
Passes the vertical test.
Passes the vertical line test. Any vertical line I draw will at most cross the graph in one spot. So, my A's are going to be blue. Yes, it's a function. Okay? B, while we're here. My B's are going to be red. Does the relation have an inverse?
Yes.
Did you say yes and no? Makes it hard for me to ask why then when you give both answers. So
Yes.
Yes. Yeah,
Yeah.
it never, it's just the same thing.
yes, why?
It never crosses more than once going.
Passes the horizontal line test.
Passes the horizontal line test is what she's trying to say. In other words, if I start drawing horizontal lines, is it ever going to touch the grass more than once?
No.
No. So yes, and here's your reminder, it passes the, this one's all about horizontal line test. Now, special vocab. What do we know about graph A?
And asymptote or two asymptotes.
What vocab did I just introduce on the bottom of the front page? One-to-one. It's a function and it has an inverse. So this is an example of something that is 1-to-1. Did they ask me that there? No. Am I throwing it in anyways? Yes. Fair enough? Okay, because yes, it's a function. Yes, it has an inverse. Okay, ready for graph 2?
Yep.
A.
No.
Ooh. He says no.
Absolutely not.
Yes.
Not a function? Because why?
F does not pass the horizontal. Nope. Vertical line test.
Okay. It fails the vertical line test, right? There's one example of failing the vertical line test. Okay?
And yes.
B.
Yep.
Does it have an inverse?
Yes.
No.
Well, I can't tell
It has
the
to
lines
pass,
different.
it has to pass both instance. It doesn't pass the first one, does it not have the second one?
It can be an inverse and not be a function. Or it can have an inverse, excuse me, and not be a function.
I'll go
Yes.
with yes.
Yes. I'm gonna go with yes.
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 Does it pass the horizontal line test?
Yes.
Yeah.
And here's the deal. Like here, it crosses once, yes? What's happening right here?
We have some absent.
Okay, and those are fine, right? But every place you draw otherwise, does it just hit once?
Yeah.
Yeah. So, yes, it has an inverse. While it's not a function, it does have an inverse. So is it 1-to-1?
No.
No, it's not 1-to-1 this time. Got it? Okay. Graph 3.
No.
Is it a function?
No.
No, because it fails the
Vertical line.
vertical line test.
No.
Does it have an inverse?
No.
No.
No, because
It passes the. It does
Fails
not
the
pass the
horizontal
horizontal line.
fails the horizontal line test. Okay. I didn't draw the lines there. Are we okay?
Yeah.
Okay. And graph 4.
Yes.
Is it a function?
Yeah.
Yes.
And what's happening here? Right here.
Asymptotes.
Those are vertical asymptotes, right? Just testing your knowledge, but you've learned that looks like vertical asymptotes, right? But other than that, passes a vertical line test. So, yes, it's a function. Does it have an inverse?
No.
Because
It fails
Fails horizontal line.
fails the horizontal line test. So, no, it does not have a function, or does not have an inverse. Vocab confusion, sorry. Okay. Questions there? Okay. So, example 4 is what we did last year in Algebra 1. You just need review. Why do I keep saying Algebra 1 last year? That is like the second or third time I've done this period. Okay. Algebra. Algebra 2 specifically, but find the inverse for each of the following if one exists. First of all, what do you know about f of x? It's the same as
Y.
y. We talked on the front page. How do you find an inverse? You switch x and y. So we're going to take that equation, and the y becomes an x. The x becomes a y, and then you're going to have to solve for y. Okay. We'll do that tomorrow because I'm afraid I'm going to get caught in the middle, and we'll do that tomorrow. Actually, you guys can do that tomorrow. You don't even need me, right?
No, no,
Try to do it.